Bismillahirrahmanirrahim. Assalamu alaikum. How are you, students? Today our course is Inorganic Material Chemistry and course code is CAM 3115. In this subject we will discuss properties of advanced materials. In your syllabus there are different properties of advanced materials: mechanical properties, electrical properties, optical properties, dielectric, magnetic, and some chemical corrosion properties that you have to study in this course. First we will start from mechanical properties. In this lecture we will discuss mechanical properties and its detail. Key concepts that we will discuss in this course under this topic are properties of advanced materials. And first we will discuss mechanical properties. For mechanical properties, some parameters are discussed or important to discuss, and then these parameters or these basic terms will be stress, strain, hardness, and strength. We will talk about elasticity and plasticity, ductility and brittleness, toughness, malleability, and then we will discuss what are advanced materials and what are nanomaterials. Then the properties of advanced material. We will discuss mechanical properties. So when we talk about mechanical properties, then we should know that what are mechanical properties. So properties which can be determined are observed by the application of mechanical force or load that are known as mechanical properties. So what is mechanical force? Mechanical force is a force that requires direct physical contact on that material. We will further discuss mechanical properties in detail. So we can also define mechanical properties as the properties of materials that determine its behavior under applied forces. So it is known as mechanical property. And mostly mechanical properties are related to elastic or plastic behavior of that material. And these properties are expressed as a function of stress, strain. As we already discussed, that key concepts that we study that are important to know are stress, strain, and that can be strength and other properties, etc. So a sound knowledge of mechanical properties of materials provide the basis for predicting behavior of materials under different load conditions and designing the component out of them. मैकेनिकल प्रॉपर्टीज इम्पोर्टेंट क्यों हैं? इसमें एक तो इसमें डिफरेंट टर्म्स डिफरेंट जो कंडीशन उनको पढ़ते हैं. जैसे हमने स्ट्रेस की बात की, स्ट्रेन की बात की, या हमने टफनेस, उसकी हार्डनेस, डिफरेंट उसके पैरामीटर्स हैं जिनको मैकेनिकल प्रॉपर्टीज़ को जो डिस्क्राइब करती हैं. सो किसी भी जो प्रोडक्ट है उसको आप बना रहे हैं, मटेरियल को सिंथेसाइज कर रहे हैं, तो उसकी मैकेनिकल प्रॉपर्टीज या मैकेनिकल स्ट्रेंथ उसकी हर एस्पेक्ट से देखना बहुत ज़रूरी होती है कि वो अंडर दैट कंडीशन उस लोड को जो है वो बेयर कर सकती हैं या नहीं कर सकती. उसकी जो डिज़ाइनिंग की गई है वो उस एनवायरनमेंट के लिए परफेक्ट है या नहीं है. तो इस पर्पज़ के लिए हम मैकेनिकल प्रॉपर्टीज़ जो है उसको स्टडी करते हैं. First thing that we will discuss in this topic is strain and stress. So different experiences or experiments show that any material subjected to a load may either deform, it may yield or break depending on its magnitude of load and the nature of material. So any material that is subjected to any force that may deform, or they may break, or they may elongate, or there may be change in length or its shape. So this change depends on the magnitude of load and the nature of that material. First we will discuss stress. What is stress? It is defined as it is internal resisting force offered by the body to resist the deformation per unit cross-sectional area of that body. So mathematically, we can say that stress is expressed as a force divided by cross-sectional area. In this figure, on the left side, you can see that F is force that is applied on both sides of that material, that body, and A naught is cross-sectional area. So stress is denoted by sigma, and it is you can express it as force divided by cross-sectional area, or you may write it as F over A naught. Before we discuss stress, what is strain? Strain is the dimensional response given by material against mechanical loading or force or deformation that is produced per unit length. So mathematically we can say that strain is a change in length divided by original length. So it is the ratio of change in dimension, change in length of that material to the original dimension or the original length of that material. So strain will be delta L over L. Delta L is change in length and L is its original length before applying the force. Next is hardness. So it is property of material that resists penetration. In this example, in figure, you can see that you can clearly understand the hardness. It is property of material that resists penetration. कोई भी फोर्स जब आप अप्लाई करते हैं किसी भी मटेरियल पे तो उस पेनिट्रेशन को रेजिस्ट करती है. So next property is strength. The property of material that resists the external load or force without breaking is known as strength. And strength determines the ability of material to withstand stress without failure. In this picture you can see if you have a flexible ball point and you apply force on it, but it will not break after applying the force. It means it have a strength. It resists the external force without breaking. So the maximum stress that any material will withstand before destruction is called ultimate strength. So in this figure, in both figures, you can see the example of strength. Next, we will discuss elasticity, the property of material by which it returns to its original shape after removal of load or force. It is known as elasticity. You can take the example in this figure. You can see elastic. If you apply a force, if you stretch it, it will go back to its original shape. Then it is known as elasticity. This property is known as elasticity. In this example, you can see these two blocks that on the left side you apply a force on it, and on right side you can see there is a change in its length. But after removing that force, it returns to its original shape. Then we say this property is elasticity, and this material has elasticity in it. So it cannot break or it cannot change its shape after removal of that load or force. We can also define elasticity as the property of material by virtue of which deformation caused by applied load disappears upon removal of load. That you apply any force and then after removing that force, that material returns to its original shape. Then it is known as, this property is known as elasticity. So elasticity of materials is the power of coming back to its original position after deformation when the stress or load is removed. In this figure, you can see that this maroon color, first on the left side, you can see that this is original material, and then you can also see in the second image, you can see when force is applied, the bonds are stretched and the length of that material is changed, but after removing that force, these bonds return back to its original position, and that material shape is not changed, it's come back to its original shape. It means this material is elastic, and this material has elastic properties. It has elasticity in it because after removal of force, it returns to its original shape without changing its shape. It comes back to its original shape. So we can say that elastic property is reversible property. Next term is plasticity. Before we discuss elasticity, in which you apply a force on a material, and that material after removal of force come back to its original shape. But what happens in plasticity? It is property of material by which permanent material deformation takes place after the removal of load or force. For example, in this picture on the left side you can see L, that material you apply a force and the length of material is L, but when you remove that force, after removal of that force, the change in length occurs, like the original shape of that material has changed, deformation takes place. So this property is known as plasticity, in which permanent material deformation takes place even after you have removed the force or that load. We can also define plasticity as the plasticity of material is its ability to undergo some degree of permanent deformation without rupture or failure. So plastic deformation will take place only after the elastic limit is exceeded. It increases with increase in temperature. So in this figure you can see the left side first image, you can see this is original length of that material, and you can also see the position of that atoms or bonds. After you applied a force, then what happened? Then these bonds stretch and there is a change in number of positions of bonds and atoms, and after removal of that force you can see that it returned back, but it cannot return to its original shape. So it means this material don't have elasticity, but it has plasticity, that it is not completely break, but it cannot come back to its return to its original shape. So there will be a little bit change than that of change in length than that of original material. So in this graph you can also see the plasticity term, and plasticity mean that this change is permanent. It will not go back to its original shape. This graph shows the stress and strain curve. It shows the elasticity and plasticity for materials. On the x-axis, here is strain, and on y-axis, stress is applied. So in first, you can see where is elastic deformation. When you apply the stress, there will be elastic deformation. Then you apply a force and it will come back to its original position up to that red point, red line. After that, you further apply that stress or force and its length will change. It will be changed from its original length, but it will not break. Further applying stress, then you can see their necking will appear like before breakage. That material will become more weak, and there will be one point when you further apply the stress, it will break. This material will break. So this curve shows the elasticity, plasticity, and the failure of stress, that up to which extent that material can withstand or can bear that stress. So next property or term that we can discuss under the mechanical properties is ductility. And ductility, the property of material by which it can drawn into thin wires without any rupture, then we can say that this material is ductile or it has ductility. Next is brittleness, the property of material in which no deformation takes place by the external load, and it may break or rupture. So it is known as brittleness, like it don't have any flexibility. When you apply any external force, it will directly break or it will rupture. So in this figure you can see ductile material, and also you can see brittle, fracture or brittle material. You can see the glass is an example of a brittle material. Toughness, the property of material by which that material can bend, that can twist or stretch under high stress without any rupture. We can say that this property is known as toughness. ये वो प्रॉपर्टी जिसमें आप मटेरियल को बेंड कर सकें, उसको ट्विस्ट करें या स्ट्रेच करें अंडर प्रेशर, अंडर स्ट्रेस और फोर्स विदाउट एनी रप्चर, और उसमें कोई उसमें ब्रेक के जो रप्चर ना हो, तो उस प्रॉपर्टी को आप क्या कहते हैं? टफनेस. Next is malleability, and malleability of a material is its ability to be flattened into thin sheets without cracking by hot or cold working. So gold is the most malleable metal that can be converted into thin or flattened thin sheets. So when it is hammered with the when force is applied or stress is applied, then it can be changed into thin sheets without cracking. So gold is the best example of malleable metal. Our topic of discussion is mechanical properties of advanced material. So we should also know about advanced materials. What are advanced materials? What is meant by them? So an advanced materials can be said to be a material which has engineered properties that are created through the development of specialized process and synthesis technology. यानी एडवांस मटेरियल्स वो मटेरियल्स होते हैं जिनको आप एक स्पेसिफिक प्रॉपर्टी के लिए उसको स्पेसिफिक मेथड से आप जो स्पेसिफिक प्रोसेस से जो है उसको डेवलप करते हैं, बनाते हैं, और जिस तरह की आपको प्रॉपर्टी चाहिए होती है उस तरह का मटेरियल आप जो है उसके अकॉर्डिंगली उसको प्रिपेयर करते हैं, और उसमें उसका जो है हर उसकी प्रॉपर्टी के लिए मेथड जो है वो स्पेसिफिक यूज होता है. When we talk about advanced materials, then the latest materials that are mostly being used as advanced materials are nanomaterials, and that are under considerations and that are mostly widely used and studied. Our nanomaterials are also known as nanoparticles. You already know about nanoparticles. What are nanomaterials? You have discussed or you have studied this their introduction. So Generally, I will tell you in one or two lines that what are nanomaterials and nanoparticles. So nanomaterials or nanoparticles are that materials which have size in the range of 1 to 100 nanometer, and in nanotechnology we define a nanoparticle, a particle, as it is a small object that behaves as a whole unit with respect to its properties. So particles of any shape with dimension that is in the range of 10 raised to the power minus 9 to 10 raised to the power minus 7 meter are called nanoparticles or nanomaterials. So next we will discuss the mechanical properties of advanced materials. So we talk about nanoparticles or nanomaterials. They show different mechanical properties relative to their as compared to microparticles or bulk materials that are bigger than that microparticles or micromaterials. So these nanomaterials provide more effective options for the surface modification of many devices in mechanical strength, or they are important to improve the quality of nano manufacturing or nano fabrication. So particle size reduction to nanometer range can pose new technological challenges such as particle agglomeration. So mechanical properties of nanomaterials increases with decrease in size, because if size is smaller, then there will be less probability of finding imperfections, and these imperfections in nanomaterials are dislocations, these may be vacancies or some grain boundaries. These are terms we will discuss later on. So we can say that mechanical properties of nanomaterials increases with the decrease in size, because if there will be smaller sizes that will be in nanometer range, then there will be less imperfection, there will be less defects, there will be less dislocations or grain boundaries. So strength of materials improves significantly as the particle size decreases due to the perfect free defect free surface. In case of nanomaterials, we say that there are less defects, so their properties can be improved. And further, hardness and yield strength of material also increases as particle sizes decrease. So elasticity and toughness of materials increases as particle size is reduced. So overall we can say that mechanical properties can be improved if the particle size is smaller, and this may be due to the less number of imperfections and less number of dislocations or less defects. So in addition to specific properties of interest for a particular application of material, its elasticity, strength, hardness, brittleness, and other properties determine whether an application is possible or not. So no matter how good the electric, magnetic, chemical, or other properties are, a material is of no use if it does not fulfill mechanical requirements. For example, for one material, we are saying that it has good electrical properties, it has good mechanical, it has good magnetic properties or chemical properties or other one. So if this material is not mechanically strong, then there is no use of these properties. So this largely depend on the structure and on the kind of chemical bonding. And mechanical properties are usually anisotropic. Anisotropic means that they depend on the direction of applied force. As we apply the force, there is some change in the length, and in case of elasticity, that we said that we applied some force and there is a change in length and it comes back to its original shape. So this property is anisotropic, like they have some dimension or direction. There is some dimension for the applied force. So, for example, if we take the example of diamond, a framework of strong covalent bond is present in diamond that results in higher hardness and compressive strength. So we can say that the diamond is more strong due to the framework of strong covalent bonds in it. So if we talk about characteristics of nanomaterial with respect to mechanical properties, we can say that by reducing the grain size, lighter material with enhanced mechanical properties can be produced. For example, if the size of material is less and its grain size is smaller, grain size it means when its crystallites is smaller, then material will be lighter, and with light material we can produce mechanically strong materials. So nanograins are more resistant since they have no defect inside as compared to micrograins. So we can say that nanocrystalline copper is 3 times more resistant than usual copper because nanocrystalline copper has less defects, due to which it will be stronger or more mechanically more strong. So they are also more ductile since nanograin glide is much easier. So they can be converted into wires because these nanograins can glide or slide onto each other, and we can convert them into wires.